So here we're going to rationalize this denominator. We've got cube roots, so we need perfect cubes. So I need to multiply the top and bottom to make a perfect cube. So here I need to multiply by 49 to make this a perfect cube of 7. And I need to do the same for the top. And then when I work this out, I'm going to end up with 32 cube root 84 times 49. Oh, that's a big number. So it looks like I probably could have done something a little bit different to avoid these big numbers. But I'm dealing with these big numbers now. So 4116. And this becomes 4 times the cube root of 343. Okay, we can simplify the denominator here. This becomes 32. And there are some perfect cubes involved in here. Okay, in fact, there's a perfect cube of 7 cubed. Okay, so if I divide that by 343, this is actually equal to 343 times 12 over 4, and then the cube root of 7 is, cube root of 343 is 7. Now, this strategy involves keeping track of and knowing some of your higher power or bigger number cubes, which is some of you may or may not be that familiar with. So I'm just going to finish this off. I'm going to simplify this. So it's 32 times 7 times cube root 12 all over 4 times 7. Well, those 7's cancel out, and this becomes 34 over 4 is 8, and that's cube root 12. So there's my answer. Now, an alternative would have been, and this is something I mentioned before, when we can simplify fractions, we should try simplifying those fractions whenever we can. In fact, that fraction simplifies, and 84 is divisible by 7. Those indexes are the same, so we can divide that. So 84 divided by 7 is going to be equal to 12. So we can get the solution without rationalizing this denominator if we had simplified this fraction first. Okay, so this is a much simpler strategy, so this is something good to remember. If you don't, you just have to do a little bit more work, but if you remember to try to simplify the fraction first, that's always a better strategy. Okay, so here are some binomial radicals. So we need to make sure that we understand how to multiply out our binomial radicals. Okay, again, our model for multiplication is area. So we have x plus root x, x minus root x. We're going to have x squared, x root x, negative x root x, and we're going to have root x, negative root x times positive root x is going to give us positive x. So when we have these, and if you recognize that this is a conjugate, these terms always cancel out. So we're going to be left with x squared minus square root x squared, which is just x.